In example one from your myAP questions, we're given a slope field here, and let's go ahead and take a look at what the actual question is asking us to do here, and then we'll use that slope field to help us answer it. So it says the slope field for a certain differential equation is shown above. Which of the following statements about a solution to the differential equation must be false? So pay very close attention to the words that are written down in the question. So we want to select the letter or the choice that must be false. Let's take a look at A. A says the graph of the particular solution that satisfies f at -3 is equal to 2 is concave up over the interval -3 to 3. So let's go ahead and we'll do this one in, whoops, I don't want to circle it because it might not be the right answer, but let's just go ahead and we'll put a color on it here. So we'll do this one in blue. We'll just underline it and we'll see what happens. So the particular solution goes through -3, 2. So let's go ahead and take a look at -3, 2. -3, 2 is this point here. Keep in mind the scale with this is not every slope is 1 on the tick marks there. So 1 would be right here, and then 2 would be right here. So if you don't pay attention to numbers, that's a gotcha. And -3, 2, we want to try to graph the equation of that line, that particular solution. So as we, oopsies, I don't want to go down that far. As we continue this around these slopes, we're going to start to shallow out here. We should have a minimum right here. And then as we continue up, we look like we have kind of a asymptotic behavior right there. So let's go ahead and read the question or the answer again for part A. So it says f at -3 is equal to 2. That solution has to be concave up on the interval -3 to 3. Well, it appears to me that the shape of this graph is concave up. So this one actually could be true, and we don't want to list that as one of our answers. So we'll switch now to a different color. Try red for this one. The graph of the particular solution with f at -2 is equal to -2 has a relative minimum when x is equal to -2. All right, well, let's see about that one. So we've got -2, -2. That's right here. It looks like there's a horizontal tangent there. That's looking good for us. So that equation is going to look like this. And that particular solution is going to kind of look like this. And so what we can see here is we can see that the slope of the tangent line when x is -2 is horizontal right there. And then actually um, the slopes change from negative to positive right around x is equal to -2. So this indicates to me our slopes of our tangent lines are changing from positive to negative and exactly 0 at -2. So I think probably this one could be true. So we're going to mark off B here, and we're going to switch colors once again, and we're going to take a look at part C. So it says the graph of the particular solution that satisfies f at 0 is -2 is concave up over that interval. So let's go ahead and just try to draw the solution at 0, -2. So let's see here. 0, -2 is there. And so that solution is going to look something like this. And then there we are right there. So tough to tell on this one a little bit, but it appears that the shape of this graph is concave down. And we only want to look at the interval -1 to 3 here. So we pretty much got it. So there's that curve right there. -1 would be over here. And if we take a look at this, all the slopes of those tangent lines are decreasing. So if the slopes of the tangent lines are decreasing, that means the second derivative must be negative. And if the second derivative is negative, that original function, that particular solution, the one in green up here, must be concave down. So this one is probably the right answer. I like to look at all the rest of them though too. And we got to pick a different color here. So let's see if we can pick something that will stand out. And so part D says the graph of the particular solution that satisfies f at 1 is equal to 0 is linear. So let's go to 1, 0. So here's 1, 0, and it looks like all of those ones happen to be a straight line. And oh, well, that's what this is actually saying. So the graph of the particular solution is linear at 1 comma 0. So we know this can't be the case. So we'll have to go back to green here. So actually, the one that we thought was false, which is the answer in this case, is C, and that is the correct response.